Hi there. Today we're doing another video on Azure Pipelines on Docker. So far, we've been running our containerized agents on my local Mac, exploring everything from basic deployments to persistent storage with volumes and bind mounts, and even Docker and Docker scenarios. Today, we're taking our Docker host from local to AWS cloud. Why are we making this move? Well, I've got two reasons. First is great integration with AWS resources. Your pipeline can now directly interact with AWS resources like S3, RDS, Lambda, you name it. Secondly, it's easy and quick to scale. And that's one of the core benefits of cloud computing. You need more agents, you can scale it up. When your pipeline's done, you can scale it down. So you only pay for what you use. Now, what are we doing in this video? Same as when I started this series with my local machine installation. I want to keep it basic and simple. I want to focus on deploying Azure Pipeline agents in containers running a simple Azure pipeline. I'm keeping it simple because I want to focus on telling you about the service, which is Amazon ECS with AWS Fargate. ECS stands for Elastic Container Service. Why I chose this option, what other alternatives exist for hosting agents in AWS, and what you need to know to get started. Let's talk about what are our options for hosting Docker-based agents in AWS. There are several approaches that I can think of, and each of them have different trade-offs. The first one is EC2, and you can have EC2 with auto-scaling groups. In this option, we have to manage the EC2 instance. We have to install Docker on them. We have to handle patching, security, scaling rules. You have full control, yes, but you also have full responsibility. The next option is ECS with EC2. You still manage the EC2 instances that form your cluster, but ECS handles the container orchestration. There's less infrastructure to manage than raw EC2, but you're still responsible for the host machines. There's then EKS, or Elastic Kubernetes Service. This is full Kubernetes orchestration. Yes, it is powerful, but it is complex. It's great if you're already invested in Kubernetes, but I think it's overkill if you just want to run some containers. Then, lastly, there is ECS with Fargate, and that's what we're using today. That is serverless container compute. You define what containers to run. Then AWS handles all the infrastructure. There's no EC2 instances to manage, no patching, no server scaling, just containers. For this demo, I chose ECS with Fargate because it has the lowest operational overhead. I want to run containers, not manage servers. Fargate lets me focus on the agent configuration and pipeline, not on instance types and OS patches. But keep in mind that in a real enterprise environment, your choice depends on your specific requirements. Cost optimization, control needs, existing AWS investments, and team expertise. Before we dive into the deployment, let's understand the key ECS concepts that we need to know. There's the ECS task definition. Think of it as the equivalent of the Docker Compose file. It's a JSON document that describes how your containers should run. It specifies things like which container images to use, the CPU and memory requirements, at both the task and the container level, environment variables and secrets, port mappings if you need them, volume mounts, including EFS volumes, network configuration. So for Fargate, this is always AWS VPC mode. Logging configuration, that's typically CloudWatch logs. And in AWS, there's always IAM roles. So you have to think about the IAM role for the task. Lastly, you can configure health checks and dependencies between the containers. So just like Docker Compose, it defines how multiple containers work together locally. A task definition defines how your containers work together in ECS. What's the difference between the Docker Compose file and the task definition? In task definitions, it focuses on defining the containers themselves. The orchestration aspects, such as scaling, load balancing, service discovery, those are handled separately. Then there's the concept of task and a service. We want to understand it because a task is a single running instance of our task definition. Think of it as a one off container run. We start it, it runs our pipeline job, it stops. Great for ephemeral agents or on demand workloads. Then we have a service. It maintains a desired number of tasks running continuously. If a task fails, the service starts a new one. It handles load balancing, rolling updates, and auto scaling. It's great for long running agents that need to be always available. For this demo, we'll use tasks, running them on demand. We'll explore services in another video where we'll look at scaling and persistent agents. Let's look at our Terraform deployment. I'm using obviously infrastructure as code because it's repeatable, it's versioned, easy to tear down when we're done. So here's what we're building. Firstly, we've got the usual stuff such as our Terraform statement and provider, where we define the region and which AWS profile I'm using. And here on my right is the variables TF file where I define the value of what those variables are. The first resource we have is the ECR repository. ECR stands for Elastic Container Registry. This is AWS's Docker registry. It's similar to Docker Hub or Docker.io, but it is private and it's integrated with AWS. We will be pushing our agent images here. And also note here, there's this image scanning configuration where there will be some security scanning of the vulnerabilities of the actual image to see if the packages used within the image have any vulnerabilities. So that comes in handy for security. We're also using Secrets Manager to store our Azure Pipelines credentials securely. In here, we will be putting in our token, our PAT token, the pool name, and organization URL for Azure DevOps. The task pulls these at runtime, so we never hard code our secrets. And again, in AWS, we always need to define what role to give the task so that that task is able to access and have permission on accessing certain resources and conducting any actions that it will take. Here we have the assume role policy where we're saying that only this ECS task service can assume this particular role. And we're attaching a couple of policies here. One is the AWS managed policy for ECS task execution. So it's able to execute ECS tasks. And the other one is to be able to get the secret value from Secrets Manager. Next, we have what is called an ECS cluster. What an ECS cluster is, it's a logical grouping for our tasks. With Fargate, the cluster is just an organizational boundary. AWS manages the actual compute. I'm also creating a CloudWatch log group. I'm putting in here the retention period and the name of that log group. That's where our agent logs go to. It's essential for debugging and monitoring. Last but not least, and the most important bit here is ECS task definition. Now, this is the blueprint defining how our agents run. Notice in the Terraform, we're defining two agents in one task definition. Both containers will be running together in the same task, sharing the same network namespace. This is the container definition in JSON, where it has a for loop for the number of agents. So it's expecting the agent names to be in a list, which we have here. I put down these two as the agent names, agent one and agent two, and it's a list of strings. So it will just loop through how many is in that list and get the names from that list to be able to create each container for the agent. So with this ECS task definition, we have used the network mode AWS VPC, and that's always the case for Fargate. Here we define the number of CPUs in memory, which we have defined in our variables file here. So we're saying it's just 0.25 of a vCPU because 1024 is equals to one CPU. The memory, I'm putting 512 MB, and the CPU architecture we're using is ARM. The operating system is Linux. For our ECS task definition environment variables, one of them is the agent name, which it gets from the agent names list here in that for loop. And the others are actually taken from the Secrets Manager resource that we've created above in this Terraform template. So it's getting the AWS Secrets Manager secret from that AZP credentials and using that AZP token, AZP pool, and AZP URL variables within Secrets Manager. So if I go up to the Secrets Manager statement definition here, let's expand that. So here is where we create the secret in Secrets Manager. The secret is called AZP credentials with tags, and the actual secrets is created as a secret string with these key value pairs. And it's taking from the variables file, AZP token pool and URL, which in turn gets it from a tfvars file. So that tfvars file is where I actually define the values of the secrets, like my pat token, my Azure DevOps URL. And this is the normal flow where so that you don't have anything hard coded in the code. Normally with your tfvars file, that stays local on your machine and you don't deploy that. So everything stays dynamic and no sensitive data should be going to your remote repository. So going back to the ECS task definition with environment variables here, and you'll see this better when we have deployed the resources in AWS. We have three options with managing environment variables in ECS. First is direct environment variables. So this is like the agent name that it's going to be plain text encoded into the ECS task definition. We don't do this with secrets, obviously, because it's going to be visible in the console, the logs, and the task definition history. The second option is using the SSM parameter store. This is good for configuration that might change, and it's also free for standard parameters. We use this again for non-sensitive configuration. And lastly is Secrets Manager, which is what we're using because we have sensitive data like our PAT token. So Secrets Manager is great because it's got built-in support for rotating keys, for example. It's got built-in fine-grained access control, audit logging. There is some cost, but it's worth it for sensitive data. When the ECS task starts, Fargate pulls the secrets and injects them as environment variables into the container. The application code just reads environment variables. It doesn't know they came from Secrets Manager. So I will now build our environment with Terraform. With a Terraform apply auto approve. And while it's deploying that, let me just share the Docker file. If you've seen my previous videos on Azure Pipelines in Docker, you will probably be familiar with this Docker file. It's the exact same Docker file that I've used throughout. And this is the Docker file that's based on Microsoft documentation on hosting Azure Pipelines agent in Docker containers. But note here, we continue to use ARM architecture. This must be consistent with the infrastructure we deploy in AWS. In our Terraform, you remember we defined the runtime platform for the operating system, family as Linux, and CPU architecture. This must be consistent. Otherwise, it's not going to work because ARM and x86 have different instruction sets. An ARM image won't run on x86 infrastructure and vice versa. And this happened to me the first time I deployed ECS with Fargate. By default, it just creates it with x86 infrastructure. And I was wondering why it was my ECS tasks were failing to run. That's because of this incompatibility. So why did I continue using ARM? Because I've already started using ARM. My Mac runs on ARM. ARM is also generally cheaper than x86 for the same performance or even better, and especially for Fargate, but check your specific workload needs. Okay, so our Terraform deployment is done. So let's check what we have here with our ECR. It's created our repository. Let's check on ECS. I've got my demo cluster that's been created, and there should be a task definition here. It's showing colon 5 because I've ran this a few times before this video. And it remembers if I use the same name, even after tearing down the infrastructure. And this is where we've defined the secrets with the mapping for the token, the pool, the URL, and the environment variable where we're using the AZP agent name variable. We also have the secret created here, AZP secret credentials. I'm now going to build the Docker image. So I'm going to change directory to my Docker directory where our Docker file lives. I'm going to save the image tag value and run this Docker build command. See this image tag here? It uses this specific syntax for defining the location of the repository for my images. When you're building Docker locally and running it locally, all I needed to define is this bit here, which is the name of the Docker image. I didn't have to push the image to any remote repository. If I use just that basic tag and did a push, it would have just pushed by default to Docker Hub, which is docker.io. And we don't want that. So at the start of the video, I mentioned we're using ECR, which is a private repository. And so you have to name it a certain way, which is the name of my repository, which if we go here to ECR, we can see the name, the URI that we have is the account name with the DKR ECR dot region, amazonaws.com / the tag of our actual image. So this is just telling Docker that I want to use my private ECR repository when I do a push later on. Then, because this is a private repository, I need to get a temporary password for my ECR by running this AWS CLI command and feeding that into Docker. So it will have that password. Lastly, I will do a Docker push. Okay, that's great. We should now expect to see our images in here. So here's our image with the latest tag, and its size is 456 MB. Let's continue with the rest of the deployment. So we now want to start the ECS Fargate task. First, I want to get some of these variables. One of them is the task definition ARN, the cluster name, the default VPC. So for this demo environment, I'm just using the default VPC that came with my AWS account. Again, note this is just a demo environment for simplicity and ease to deploy it. I did not bother creating private subnets. This is just running on public subnets. So my ECS task will need public IPs. It will have direct internet access, which obviously in a production environment, we won't be doing. So let's continue loading the values. We need the default subnet, the default security group. Again, that default security group, that's not going to make the cut for a production workload because that's allow all inbound and allow all outbound. That's not good. Here we want to run the task with all those values that we've loaded. Here, notice we're saying, yep, assign this task with a public IP. So here it's now running the task. We go back to the console. So here's our task. It's saying the status is still pending. The desired state is for it to be running. It's using this task definition with the version 5. And if I go drill down into it, we can see it's using the operating system and architecture we've defined, the CPU size and memory, the task execution role that I've defined, its private IP and public IP. And finally, we have our two containers named AZP Agent 1 and 2, and they're both in running state now. So if I go to my Azure Pipelines, have a look at the agent pool, we should expect to see our two agents come up online soon. While we're waiting for our agents to come up online, let's just quickly review what just happened. First, Fargate provisioned the compute resources. We didn't touch any EC2 instances. It pulled our container image from ECR. It retrieved the secrets from Secrets Manager to be able to then use those credentials to talk to Azure DevOps. It injected those secrets into the container as environment variables, and it started both agent containers in the same task. So here it looks like my containers failed to start. And after checking my path, it looks like the path I was using was expired, which is great because which I've now revoked and regenerated. So this is a good coincidence because I can show you the other way of starting a task, which is through the console. So to start the task, you just go to the cluster, go to the task tab, and run a new task. Another way is through the task definition. Go to the task definition, and I just click on deploy. Notice here, I've got a couple of options, which is to either create or update an existing service or run it as a task. So for this demo, let's just stick to the task where I just use the default values, everything default, hit create, because the default values will include having a public IP. Hopefully this will start successfully this time. And now it's created our agent successfully. We've got both agent 1 and agent 2 online. Now let's try and run our pipeline. While it's running, let's have a look what our pipeline definition is. I've used the pipeline used in a previous video on persistent storage, where it's using the default container storage to prove that each container is independent and they don't share containers. So there's a couple of stages, a build and deploy. The build stage is where agent 1 builds the artifacts into a temporary directory, and then agent 2 does the deployment. And here we're going to see agent 2's stage or task of deploying fail because it can't grab that shared artifact. But I've also injected just a couple of lines to show the host name and what the agent OS is, because I'm curious what it will look like when it's running in Fargate. So for the first building task, it will just make a directory, save it in that TMP directory, save all these dummy application files and zip it up. And with agent 2, We know this one's going to fail because it's going to try and get that artifact from agent one's shared or TMP directory. So the first build was successful. Here we can see it's using agent one with Linux as the OS, the IP address, which is the public IP address. And here is the building task, adding all these dummy files and zipping it up. And this is the second stage where it ran this command line step successfully. Gotta refresh that. It's using agent 2, same OS, same public IP. And here it fails to deploy that because we're expecting that anyway. Okay, going back to our ECS task, here we have our first task, which failed because of that expired path, and our running one. Just want to show you the logs here, where you can see where all that happened for this container. So we can filter it by agent one and agent two. So we can see what's going on with agent one. Here we can see where it's actually connecting successfully to Azure Pipelines, downloading, extracting the pipelines agent, and actually running the build job. And with agent 2, we can see that it failed with running the deploy job. And this is great. We can see it all from here. See how easy it is to be able to deploy and debug and monitor especially when it is in your production environment. And I forgot to show you the logs for that failed task. With the stop task here, we go to the logs. We can see here the clue. It's saying check that your account, the Azure DevOps URL is correct and that the token is valid for that account. When I checked the configuration, I was able to confirm that the PAD token that I use just expired today. Let's recap what we learned and some important considerations. We built and deployed Azure Pipeline agents to AWS ECS Fargate using Terraform. We manage secrets securely with AWS Secrets Manager. We ran containers on serverless infrastructure. There's no EC2 to manage. We've executed pipelines across 2 Fargate hosted agents. We then learned the key ECS concepts, the task definition, which is the blueprint for containers, like Docker Compose. We learned about the task, which is a one-off execution for ephemeral workloads. We've touched on a service, which maintains persistent running tasks. So you choose which one you want to use based on your scaling and availability needs. We also touched upon architecture decisions, such as ARM versus x86. These must match across image and infrastructure. ECR for private container registry with AWS integration. Secrets Manager for sensitive data like PAT tokens and sensitive config. We use public IP for this demo, but typically use private subnets in production. Then we touched on cost and scaling. With tasks, we pay only while running. So it's great for on-demand agents. With services, it's usually continuous availability. So it's better for persistent agents. With Fargate pricing, it's based on vCPU and memory per second. So we think about things like scaling up for peak workloads and scaling down to zero when it's idle. We also touched on production considerations like using of private subnets with NAT gateway for egress traffic, implementing VPC endpoints for ECR and Secrets Manager to avoid NAT costs, setting up proper IAM least privilege policies, enabling of CloudWatch container insights for detailed monitoring, considering EFS volumes for persistent data between tasks, implementing task auto-scaling based on pipeline queue depth. So what am I thinking of next? In future videos, I want to explore ECS services. We'll probably look at maintaining persistent agents with auto scaling. So with tasks auto scaling, we can dynamically scale based on pipeline key depth. We could probably look at VPC design, where we have private subnets, VPC endpoint for cost optimization. And we can have EFS integration, persistent storage for artifact sharing between Fargate tasks. The beauty of this setup is that we've established the foundation. Everything we add from here builds on the same concepts. There's task definitions, there's Fargate tasks, and proper AWS integration. Thanks for watching, and I'll see you next time.